So I will start with the tech talk today. So that is on large language models. So first of all, I just want to everyone know that let's keep this talk very bilingual or like bidirectional, wherever you face an issue in understanding anything, please let me know. I'll try to answer as many as questions as possible. And so I'll start
Hello?
out with my introduction.
Hello.
Yeah.
Or
Okay.
it is
So we'll
almost
start out.
everybody. Hello. Hello.
Yes, Akshay.
Actually, I can't see the screen. Is it visible to all of you? Yeah, now it's visible. So continue.
It is visible now. It is visible. Please let me know, everyone.
It's visible.
Okay. 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 Great. Okay. So I'll start out with my introduction. So I am Faizan Khan, and I am an ASC at Inzint. So fortunately, your host today for the Tech Talk. So the agenda of the talk today is like all about large language models. I hope many of us might have heard about them. So we'll basically talk about three things today. These are. So first would be what is an LLM? Okay. The second would be how do they work? And meanwhile, we'll also deep dive into transformer architecture. So it is the backbone of building LLMs and a forego of neural networks only. So many of us might have heard about them as well. And thirdly, we'll discuss about the business applications. And while discussing the business applications, we'll also be discussing few potential threats caused by them. So I will start with the overview first. So large language models. So first of all, we should know what do they do. So large language models understand and generate human-like text, aiding tasks such as text generation, language comprehension, translation, summarization, content creation, and task on automation. So basically, they do a lot of things, but these are some of the crux points. What do they do? And they large language models are basically meant to make our work easier. So the work might be anything. It might be coding. It might be related to graphic designing, video editing, and a lot of things. And as the versions of GPT and other LLMs are progressing, so a lot of new features are being added to them. Okay, moving forward, they have revolutionized various industries by processing and producing natural language efficiently. So basically, what do is we give them we talk to them with the help of prompts. So whenever we give any prompt, so they search for the text in the backend, and after finding the closest possible result, they give the answers, and that basically helps us in getting our answers and getting to know what do they do. Okay. So with this PPT, we'll also be working along with this whiteboard. I will be explaining things. So I'll be explaining the LLM first. So just give me a second. Okay. So starting with this. So I'll start with I'll take an example of GPT. So it is one of the most famous large language model. So GPT or generative pre-trained transformer is a large language model or an LLM that can generate human-like text. And we've been using GPT in its various form for 2 or more years now. So moving forward, what is an LLM? Okay. So well, LLM or a large language model is an instance of something else, which is called a foundation model. So now foundation models are pre-trained on large amounts of unlabeled and self-supervised data. So meaning the model learns from patterns in the data in a way that produces, and large language models are instances of foundation models applied specifically to text and text-like things. So here I'm talking about things like code. Now, large language models are trained on large data sets of text, such as books, articles, and conversations. And look, when we say large, these models can be tons of gigabytes in size and trained on enormous amounts of text data. We are so like we'll visualize the data here. We are talking potentially petabytes PB of data here. So to put that into perspective, a text file, let's say small text file, let's say 1 GB in size. So this can potentially store 178 million words of data. So a lot of words is just in 1 GB. So it is potentially like very large. And talking about in petabytes, then we can visualize that how many gigabytes are in a petabyte. So can anybody tell me about that? Okay. So well, it's 1 million. Yeah, that that is truly a lot of text. And LLMs are also among the biggest models when it comes to parameter count. A parameter, talking about parameter. So a parameter is a value the model can change independently as it learns. So we have also already discussed that we have to train we have to train rigorously our models. That means that large language models tend to be trained a lot of times. And the more parameters a model has, the more complex it can be. So there are a lot of parameters involved in our models. GPT-3, for example, is pre-trained on a corpus of actually 45 terabytes of data. That is again a huge amount of data, and it uses 175 billion ml parameters. Again, a large number. So in this whole talk, we will usually talking about a large number of data only. All right. So how do they work? So well, we can think of it like this: like LLM equals data, three things. The first is data, second is architecture, and lastly, we can think of it as training. These three things combinedly are really the components of an LLM. Now, we have already discussed the enormous amounts of text data that goes into these things. As for the architecture, we'll again hop onto the one of our slides, that is architecture. So basically, there are two kinds of architecture involved in the large language models. The first one is neural networks and transform, and the second one is transformers. So transformers are basically like a child of neural networks only. They are they have some advanced properties. We'll look onto them just now only. Okay. So basically, LLM is a neural network, and for GPT, particularly GPT is a transformer. And the transformer architecture enables the model to handle sequences of data. So basically, what GPT does is it handles a lot of sequential data. The sequential data can be sentences or lines of code both. And transformers are designed to understand the context of each word in a sentence. So basically, transformers are like models that understand context of each word. If we give them a sentence to read about, so they understand they understand every and every word of that sentence by considering it in relation to every other word. So suppose we take an example of a sentence, the sky is, and we give a fill in the blank kind of thing to the GPT. So this allows a model to build a comprehensive understanding of the sentence structure and the meaning of the words within it. And this is how this architecture is trained on all of this large amount of data, this all 45 terabytes now. Now during training, one thing is also we need to understand is now during training, the model learns to predict the next word in a sentence, exactly what we are asking it to do right here. So the sky is dash dash dash. It starts off with a very random guess. So let's say a guess would be any guess, people. So my guess would be the sky is bug. Okay. So the first guess we are taking is the sky is a bug. Okay. But with each iteration, the model adjusts its internal parameters. Okay. So what here means is it will process this sentence a lot many times, and it will give sequential data. Like one time it gives bug, another time it gives another word, and get to the closest possible result that would be the answer of this question. And the model keeps doing this, gradually improving its word predictions. So what the model does is, with every question answered, or every sentence completed, it readjusts itself. It keeps off it keeps on improving gradually. So this is a gradual process of training our LLM models. You might also have seen this, that a few months back, like let's say back in 2023, the GPT model which we were using 3.5 was not as powerful as our GPT-4 that we are using currently. So this is an quite obvious that with time these models will gradually improve, and we don't know exactly what's next coming. And we have already heard a rumor about the Devin AI and kind of these things. So these models will keep on improving with time. So having said that, back to our proposition, and the model keeps doing this, gradually improving its word predictions, so that we have understood. And this keeps improving until it can reliably generate coherent sentences. Forget about bug here. It can figure out it's blue. Okay. So we I gave this example of the bug, that this is inaccurate. Okay. So basically, the GPT, when it or the model that was started initially, it could have given a lot of wrong answers, including bug, including red, including water, including anything, or even somewhat close clouds. But the closest possible answer what could be is blue. So it would have taken a lot of time for our model to guess this answer, that the sky is blue. Okay. So considering this, we can come out to an inference that the model can be fine-tuned on a smaller, or we can say more specific data set with time. Here, the model refines its understanding to be able to perform this specific task more accurately. So, with time and with a lot of training involved, and with a lot of fine-tuning, and with the transformer architecture involved, these can improve with a lot of its potential, and with time. Okay. So this is basically known as fine tuning. So fine tuning is what allows a general language model to become an expert at a specific task. Okay. So how does this all fit into our business applications? So again, back to our slides. So there are a lot of business applications we can discuss of. So basically, I have figured out four mainly uh, business application that GPT helps us to perform. Number one is content generation. LLMs automate content creation for marketing, advertising, and social media, saving time and resource for businesses. So, looking at on a broader prospect, large language models have revolutionized customer support by automating. So it can provide automatic interactions through NLU, natural language understanding. NLU is you might have heard of a lot of time. NLU is quite a buzzword and stands for natural language understanding and processing. So by natural language understanding and natural language processing, large language models have revolutionized customer support. They handle inquiries, provide relevant information, and troubleshoot issues with a human-like understanding of context and intent. So this has basically enhanced efficiency by reducing response time and streamlining processes. So we might have also heard that a lot now these days a lot of language models have also been involved in directly in handling. Hello. I'm audible now, guys?
Yes, yes.
Yes,
Okay,
yes,
thank you.
Faizan.
Thank you. Okay. So LLMs can operate 24/7, addressing queries promptly. So this has eliminated the issue for people that many people quite have been facing a lot. That is, they have been working in shifts for customer support. So there have been different 8 to 5, or let's say 5 to 2. So this has basically been eliminated by large language models by intercepting into the customer support process, and they can like with the help of training and a large improvement, they can provide like uh, excellent customer support to us like masses and people. And moreover, they can learn from past interaction as well. So as we have already discovered that training helps GPT improve themselves a lot. So they can learn from past interactions to provide more personalized and accurate responses over time, further enhancing the customer experience. So that is an eventual result. So by offloading routine inquiries to LLMs, human support agents can focus on more complex issues. Exactly. So the workforces that were previously involved in handling the customer support can now focus on more complex tasks, like relevant to their industry. We will not deep dive into that right now. So overall, integrating LLMs into customer support operations not only enhances efficiency, but also ensures consistent and high quality service delivery. So this basically contributes to long-term customer loyalty and brand reputation. So taking a real life example, we might have encountered a situation, let's say I have faced any emergency in my OnePlus or let's say MI phone on a Saturday, on a normal Saturday. And I have like just discovered that the headline closes at 7 p.m. and my issue like originated only after 7:30. So now when no one is available, what would I do? Because and this happens because it is a weekend, and generally not like every time, but generally many like call centers or BPOs are also closed on the weekends. So like GPT can eliminate this problem entirely. A pre-trained model can help answer us to our queries or inquiries, or even like provide solutions to our like issues, and like whatever the like solutions that are like possible, they can suggest us. So this is eliminating the problem of like time constraint. So this was about like customer support. And what happened? And back to content generation. So LLM streamline content like creation across various platforms. So like when we say content creation, we like obviously relate to marketing, advertising, and social media. So in these fields as well, by leveraging natural language generation capabilities of LLM, like we can automate the process of generating engaging and relevant content. So these days many of might have created a lot of like AI generated videos, and we just give the model pre-trained model a prompt. Let's say I want a video on a robot playing cricket, or anything, like be it a picture or be it an image or be it a video. So what that model will do, it will take the firm prompt, and it will like generate the best possible result of an audio or a video, whatever we ask for from it, and like provide it as an answer. So this is also like a kind of a power of LLM, large language models, that they have uh, like uh, uh, gotten lately. So it is also a nice addition to their power. Additionally, LLMs ensure consistency in messaging and branding across different channels. So this what this does is it maintain a cohesive brand identity. So for any brand that want to like grow their identity across platforms, so they can leverage the power of LLMs and get it done. Furthermore, they enable businesses to scale their content creation efforts without compromising quality. Exactly. So allowing for more frequent, diverse content updates. So, like many SMEs and many companies now these days are using the power of AI for generating their content on various platforms, be it X, previously Twitter, LinkedIn, YouTube, etc., etc. So, by offloading content generation tasks to LLMs, human writers and marketers can focus on higher level strategic activities. Again, like we discussed the issue in the customer support part, that like by leveraging the power of models, we can like focus, people can BPO or call center people can focus on greater tasks. Similarly, into content generation, we can say that the human writers and marketers can focus on like more advanced or high level strategic activities, which may involve content strategy development and audience engagement initiatives, anything, campaigns, let's say anything. Ultimately, integrating LLMs into content generation process empowers businesses to stay competitive in the digital landscape by delivering relevant and compelling content to the target audience efficiently. So again, it has increased the efficiency of our like generation of our content like on various platforms. Okay, so we'll close content generation here and we'll move to the next point, market analysis. So large language models, LLMs, analyze large volumes of textual data to extract insights, trends, and sentiments for informed decision making. Okay, so we'll understand it. Uh, Large language models play a pivotal role in market analysis, obviously, by extracting these insights. So what we can do is we can give large data sets to model or to like GPT bar, whatever it is, and then we can ask it to process data and perform operations onto it and like give us the like refined data either or the any like specific question that we are supposed to ask from it. Again, it is able to do this through natural language processing NLP techniques, as I like told you in the customer support part. Again, natural language processing again is an integral part of market analysis by LLMs. Also, LLMs can analyze customer reviews, social media posts, news articles, and other textual sources to identify trends, sentiments, and emerging topics relevant to businesses. So this can detect patterns in consumer behavior. Suppose suppose we have a product in our company and we want market data on it onto it. So uh, in spite of conducting several surveys and a lot of surveys and a lot of campaigns for doing that, we can just like train our models to detect patterns in like existing consumer behavioral data, and we can also get an access to the strategies that have been followed by our competitors of our existing product, and we can like understand market dynamics in a better way. So providing valuable intelligence for informed decision making. LLMs provide us with like these leverages. LLMs also excel in processing unstructured textual data. So like if we talk about textual data, like so then uncovering hidden relationships and correlations can be like tedious task for like humans. So again, it can be performed in a very quick time, and we can save a lot of time while doing it with the help of LLMs. So again, by automating the analysis of textual data, LLMs enable businesses to gain actionable insights. Exactly. So what businesses gain is they gain a lot of like productive and actionable insights, like in a very short span of time, faster and more comprehensively. So this gives them a competitive edge in dynamic markets. So see, like markets today are very competitive, and if we want to stay at the top, then we will have to be like comprehensive in our approach, and we'll have to be very fast. So LLMs help us in achieving these properties. Moreover, LLMs can continuously learn and adapt to evolving market conditions. So, as we have already discussed, that training LLMs is an integral part of our process. So, again, in market analysis also, so we can train LLMs with a lot of evolving market conditions, evolving data, ensuring that businesses stay ahead of the curve by leveraging real-time insights for strategic planning and execution. Okay. So, next comes. Okay. So next comes in our business application is personalization. So personalization involves a lot of like things, but here we have discussed few of them. LLMs tailor product recommendations, advertisements, and user experiences based on individual preferences and behavior, improving engagement and conversion rates. So basically, LLMs enable businesses to deliver personalized experiences to their customers across various touchpoints. So as we have already discussed that once the market analysis has been done, then with the help of LLM, then the business can provide the customers across various touch points, various crux points, and like various areas where earlier it was difficult to reach to. By analyzing user interactions, preferences, and behaviors, LLMs can tailor product recommendations. It can suggest product recommendation to our customers. It can actually help us with the advertisement. It can also improve user interface. It can intercept our coding abilities as well, and like provide some improvements in a UI of our web apps, mobile applications, desktop, etc., etc. So enhancing engagement and conversion rates. So overall, this focus of personalization points to enhancing engagement and conversion rates. LLMs leverage natural language processing techniques to understand user intent and context. So this allows for more relevant and timely recommendation to our users. So let's say if let's say Amazon has already integrated its AI into its search and into its search chatbot. So basically, if I'm a customer or a consumer and I need to buy something of a particular niche on Amazon, then I'll what I will do is I will simply go to its chatbot and simply ask, like, let's say I have to buy chandlers for my from for my home. So what I'll do is, like, can you please suggest me some good companies or good products, like chandler product that I can buy from Amazon. So the with the help of current data set, the already pre-trained data model of that search chatbot of Amazon can provide me with that. So sorry. So basically, this was one example of personalization that help users. Additionally, LLMs can dynamically adjust content based on user feedback and interactions. So, like, what we can do is, like, if as a consumer, I had like, asked something from the search chatbot that has provided me with the result or with the answer. Then I can also give my suggestion that do I like it or do I no, not like it. And based on that, the chatbot will again keep on training itself, and it will get better and better with time. So basically, personalized experiences foster strong customer relationships as users feel understood and valued by the brand. So as we stay a lot of stay more and more on the platform, or let's say we were taking the example of Amazon. So more and more we'll talk with the search chatbot and take personalization and give feedbacks. So this will like improve the experiences of both user and the company. So personalized recommendations and content increase the likelihood of conversion. Exactly. So this basically improves the conversion rate by presenting users with products or services that align with their interests and needs. So the crux of this would be by integrating LLMs into personalization strategies, businesses can enhance customer satisfaction, loyalty, and ultimately drive revenue growth through more effective marketing and sales initiatives. So this was one of the uh, like uh, benefits of using or integrating LLM into business models, business application. Okay, so we haven't discussed the history of large language models. So basically, it is important to talk about the history of large language models because to fundamentally push the deep learning research frontier forward, one needs to thoroughly understand what has been attempted in the history and why current models exist in present forms. So this is basically why we should know the history, or we can say where our large language models originate. So basically, large language models have a fascinating history that dates back to the early 1930s when the first ideas of computational linguistics were born. So basically, the first ideas of computational languages and all these were born in the early 1930s. So we might have studied this in our early school textbooks, and we might be remembering that as well. And one may argue that this tracing is excessive and that LLMs have nothing in common with the old-fashioned prehistoric computer systems. So the old-fashioned prehistoric computer systems, and I can point out we might also studied about Charles Babbage, the father of computers and modern computing. So basically, talking about that time, we can argue that today's LLMs have nothing in common, but we will get an idea that LLMs are based on real hardcore deep learning and how they have evolved with time, how powerful they have become these days, and how efficiently they can help us in doing a task and etc etc. However, deep learning itself originated in 1943. So here it is also a point to be noted that the deep learning was originated in 1943 when the first ancestor of the artificial neural model was proposed by McCulloch and Pitts. So these were the founders, or these were the brains behind this whole idea. And this was exactly 60 years ago from today. So this also from how much old time these things have been in the network. Okay. Okay. So we'll discuss more about neural networks and transformers, as I have told earlier as well. So basically, neural networks inspired by the brain's interconnected neurons are computational models comprising layers of nodes, and the nodes are like comparable to neurons in real life, and these are capable of learning from data. So this gives the this only gives LLMs the power to train themselves and get better with time. So each neuron possesses input signals, and that's quite obvious that as we give input, so these will receive an output after processing. So each neuron processes input signals, applies a transformation using learned parameters, that is weights, and passes the output to the next layer. So like there are a lot of processing steps involved internally in a model or a large learning model. So like as the steps are performed, all processed output, so the till then processed output is passed on to the next layer. So through back propagation, neural networks adjust these during training to minimize prediction errors. So this is a technique like exactly back propagation. So by this, by virtue of this, neural networks adjust the inputs and during training, and this training minimizes the prediction errors in real time. So this also enhances the learning ability of our models, learning to recognize patterns and make predictions. So they exhibit remarkable flexibility and scalability. Exactly. So like these models are really very flexible and very scalable. And this is one of the reasons that we might have been looking out in the real industry, that like any real life large learning model that is capable of performing certain tasks is getting a lot of funding by venture capitalists or the big giants of the industry. This is one of the major reasons that the scalability is a major reason. So basically, flexibility and scalability enable them to excel in various tasks across domains such as computer vision, speech recognition, and natural language processing. So these are the three basic domains, and which grows out a lot of times and go into a lot of other domains. And altogether, it does make sense. So neural networks have fueled advancements in AI, driving innovations in autonomous vehicles, so medical diagnostics and recommendation system, among others. So we have already discussed the business prospects of models. So one may argue that our GPT is not a neural network. So yeah, that is absolutely correct. That the GPT is not a neural network, but there are a lot of other models as well. So we will discuss in some time all these models. There are large number of models: GPT, Codex, FIM, LLAM. So some of them are like transforms, and some of them still are based on the neural network architecture. Okay. So moving forward, transformers. So transformers architecture is like a breakthrough in natural language processing, and it was introduced by Vaswani et al. In 2017. So transformers are basically like child of neural networks. So it is based upon neural networks only, but it is an improved version of it. So Vaswani redefined how machines understand and generate language. Exactly. So this is also one of the major reasons, or one of the major force powering uh, a strong model like GPT-4, GPT 3.5. All of these are transformers. Unlike traditional recurrent neural networks, RNNs, transformers processes input sequences in parallel. So you might have listened carefully while I was discussing neural networks, that this model passes on the processed parameters onto the next level sequentially, whereas on the other side, transformers uses parallel processing techniques, and it processes the input sequences in parallel. And this has leveraged self-attention mechanism to weigh the importance of each word's context. So when provided with a lot of sentences, so they can like parallelly process the sentence, the words, each different lines, different words, different sentences of a paragraph that we have provided them with as a prompt. So this enables capturing long-range dependencies efficiently. So this is crucial for tasks like language translation and text generation. So when we perform operations such as language translation from one language to others, let's say from English to Hindi or vice versa, and text generation, or like we say that we give a prompt, like suppose I am using GPT or Bard, and let's say I like ask them to give me a paragraph of not more than 200 words on like let's say IPL 2024. So what it will do, it will use its current data sets and current training, and it will like generate the text according to based on that. So like the parallel processing ability of like transformer models like GPT have enabled us to give more accurate and give more comprehensive like text generation task and all. So transformers excel in handling variable length sequences and outperform previous architectures on many NLP benchmarks. Their architecture facilitates training on large data sets, making them scalable for real-world applications. With their ability to capture context effectively, transformers have become the cornerstone of modern NLP, natural language processing. So, because of these powers and because of these advantages over neural networks, transformers have like now become one of the like cornerstone or like a big thing in the modern natural language processing world. So, powering advancements, machine translation, sentiment listening, and language understanding. So, these are just the like end results, and transformers have like really evolved a lot, and he really emerged as one of the major giants of natural language processing world. As we move forward, certainly there are some threats or what people say like issues related with the large language models. So we'll discuss some of them. One significant concern is the proliferation of misinformation and fake content. And LLMs can be exploited to generate highly convincing fake news articles, social media posts, or reviews, which may deceive and manipulate audiences, leading to social unrest or undermining trust in institutions. So, giving it a thought, we may take an example of the early 2023, when all of us might have somewhere watched some reels on Instagram or YouTube stating that like you can control the like GPT or any large language model with the help of prompts. So yes, initially it was possible that with the help of some prompts, like let's say consider you as X and perform Y operation. So people were able to manipulate LLMs as well. But with the help of regulations and continuous oversight, this the threat has been largely eliminated. Additionally, there are risks of privacy violations as LLMs could be used to generate synthetic data resembling real individuals, compromising their privacy and security. Exactly. So, like as we have like seen nowadays that many people have created fake profiles, fake social profiles, fake like photos of people, and have been misusing it for their own for satisfying their own ego or whatever the aim is. But this is like one of the major issue related to large language models, because it is like again in the initial stage of its launch only, and with time these things can be eliminated. Furthermore, there's a potential for malicious use in cyber attacks. Yeah, so many like hackers and the non-ethical hackers have been using it for generating content that like involve phishing emails or malware laden content, bypassing traditional security measures, etc., etc. Lastly, LLMs may exacerbate existing biases present in training data, leading to unfair or undiscriminatory outcomes in automated decision-making systems. Addressing these threats require robust regulation, ethical guidelines, and technological safeguards to mitigate the risks associated with the generative AI. Exactly. So, like to combat these threats, like there are three major techniques that we can use. That is regulation and oversight. First one. Second is ethical AI practices, and like and we can also like put some technological safeguards to mitigate the risk. And by regulation and oversight, I mean implementing like robust regulations and oversight mechanisms which can control the threats posed by generative AI. So this means that governments and regulatory bodies can establish guidelines and standards for the ethical use of LLMs, including measures to like stop the spread of misinformation, protect user privacy, and prevent malicious use. These surely these regulations can like mandate AR, like transparency and accountability in AI development and deployment, let's say, ensuring that companies adhere to ethical principles and best practices. Additionally, these kind of regular audits and compliance checks can monitor compliance with regulations and identify potential risks for violations as well. So this is like a regulation oversight. And conducting ethical AI practices like means promoting ethical AI practices within organization. So let's say we are all together present in Inzint, and if like our seniors and our managers promote ethical AI practices within our organization, then the broader AI community is essential like for controlling the risk associated with generative AI. So we are like playing like we can play our part by practicing like ethical AI practices and using it for ethical uses only. Companies developing and deploying LLMs should prioritize ethical consideration. Exactly. So there are a lot of like browsers. You might have heard about Tor browser and in browser. So there we can like if you have gone through them, then you might have gone past through a lot of LLMs that prioritize unethical consideration practices. So these things should be banned to stop the like mal use of LLMs. So this includes implementing safeguards to prevent from propagation of misinformation as well. Like someone can like create a hypothetical scenario with the help of LLMs and like can spread it through social media or via various social platforms and can like create a huge stir in the society or in the like in their environment, whatever. So like there should be some safeguards on onto this as well. So moreover, fostering collaboration and knowledge sharing within the AI community can facilitate the development of best practices and standards for responsible AI use. So this can further enhance the control of threats posed by generative AI. So these were the some of the like plots we can use to control threats. Lastly, we will hop on to the market research. So the market research involved the rise of AI-based large language models like GPT-4, Lambda, Llama, Palm, and Jurassic 2. So this was spanning in the pre-2020 when the this all started. So it all started with GPT-2, which kept on increasing until the end of 2022, it was very much closer to 175 billion. When only then they have launched GPT-3. That was like enhanced version of GPT-2, and it was capable of performing better tasks and better like itself. It was in the beginning of 2021. And in 2022 it saw a major dip as well, but like with the introduction of GPT 3.5 and GPT 4, it has again gone up like very fast. Then the like progress is very steep. So this has been the rise of our model AI models so far. And I'll close it by saying that generative models are changing the way we think about machine intelligence and creativity, and have the potential to transform industries from media to finance to healthcare. So this has been said by Oriel Venier. So he is a renowned data scientist at Google, and he's the one of the faces involved behind the creation of Bard and deployment of Bard. So this is the view that he has been emphasizing on so far. Okay, guys. So thank you so much. I will be sharing these references with you. I will be sharing this PPT with you in the like group chat, and I would also like you to go through these articles. So this is one of the articles like bootcamp. This is on Medium. So like this involves the history of LLM. So this can like tell us how LLMs were generated, how LLMs idea was put forward. And the second is a like wonderful video on introduction to large language models. So this Video has been created by Google Cloud team, and it has been put for free on YouTube. So I also attach its link. You can refer to it as well. It will like give you even more deeper dive to the large language models. Thirdly, it is a video on like if like as I have discussed the transformer architecture. So if any one of you if is interested in learning more about the architecture, then you guys can go through this video as well. This has also been provided by the Google Cloud team. This has been by the author Dale. Dale is its author. And lastly, I would also want to give you my repository. So it has been a model. So I have integrated GPT 3.5 into my project. So I'm attaching the link to this repository in the resources guide as well. So you guys can go through the client and server code, and the client code has been written with React Tailwind and Redux.js. Redux toolkit has been used to manage the state globally, and the server is basically based on the code of this code. Like it is basically using WebSockets and a lot of event emitters for handling the like passing of data. You might also get to know about how WebSockets are different from HTTP servers, and obviously they are bidirectional. HTTP servers are unidirectional. So I can also give you the whiteboard access if you want. Okay, guys, thank you so much. Thank you so much for bearing with me. Thank you.
Thanks, Faizan, for this wonderful, wonderful session. So, anyone have any doubt? So you can guide, like you guys can ask.
Guys, feel free to ask me anything related to transform architecture, neural networks, or large language models, or whatever query you have. Do you have? Feel free to text me as well if you want to understand something or anything. Thank you. Thank you so much. Yeah. Hi, Vanshai. Yeah.
Hello, Faizan. Actually, I have a question.
Sure.
So, how much is it difficult to fine tune a LLM?
Pardon, please. Your voice broke. How much it is difficult to find what?
To fine tune a LLM, fine tune.
Not get. Can you write your query? I guess your voice is breaking.
Yeah, sure.
Okay. So yeah, so it is like a really like very difficult task to fine tune a LLM, because it can be like really challenging due to the resources required. So basically, large data sets or large pre-required data is required. Pre-recorded data is required to train our LLMs. So basically, like to train or fine tune a LLM, large data of required. Large data is required. Large data sets are required, and this fine tune model's performance also should align with the task that we are giving it rigorously. So if anytime a model is facing a new question to answer for, then it might obviously face some issues in answering that. But with time and with a lot of data sets and lot of recorded data available, it can train itself, and it can also fine tune to the extent that the issues are eliminated. Exactly, like fine tuning is a tedious problem right now. It is complex right now, but with time we may see that tuning can evolve our large language models to a great extent. I hope I'm able to answer you.
Okay, sir. Thank you.
Okay, guys, so let's close the session. Thank you so much.